I'd like to go over the learning objectives for EE110, Signals and Systems. Um, you might not be able to understand this if you're seeing this on the first day, and please be advised this is a bit of a work in progress. So for the high level thing that I really want you to do if you successfully complete this course is design and implement a filter to a specification. Now some of the things, these terms in here, you won't understand till the end. So probably you should see this at the beginning, right before the midterms and right before the final to get it. But you need to be able to choose what kind of topology of filter to meet the needs: high, low, band, notch, what filter order. Is it going to be second order? There's ways to implement it. Butterworth elliptical, that is not spelled right. Is the filter critically damped? Then once you have that, how will it be implemented? DF1, 2, RLC, just an RC, op amp, parallel series. Once you got an architecture set out, all right, then what are the R, L, and C values? If that, um, you know, and then there's ways that you can calculate things in Python, MATLAB, can pull things off a chart or a wizard. Then you got to verify your design in LT Spice with the Bodhi plot. Um, you have your transfer function, and then you physically implement it. This is that behavioral voltage source. And yes, so in order to understand all of this, you probably really have to have 110 Lab, which is a required course to graduate for the undergrads. If you're a grad student, I strongly suggest you do everything in the lab manual unless you want to take the course. And then another high level skill is to debug any issues that come up. Another high level skill is to decide what kind of feedback, if any, a system needs to be stable. Something else that you need to learn is how to break up any complex system signal into easy to understand task signals and systems. Um, Also, decide what analysis technique is the best to use for a given situation. So there's time domain, convolution methods, and in the frequency we've got two, Laplace and Fourier, right? So deciding which way to go is a high level task. Now, in these following slides, I have what I might consider more skills, things that you need to know, and I've got it by homework. So on homework 1, model a signal as a sum of steps and not rectangle, ramps. You need to be able to plot delta functions, step functions, and ramp functions, and identify whether something is continuous or discrete. Then on homework 2, we start getting into systems. Is it static, dynamic, linear? Are there any limitations on the linearity? Um, and then you're going to start to learn how to test these things. That means you have to derive impulse, step, and ramp responses to filters. And then I have a high level question in there about debugging a noisy test environment, and then design a test protocol for a filter, ramp times pulse width, high, low, the starting value of the input, the ending value of the input. Homework 3, derive and plot out convolution of two signals. We have a rectangular and then a kind of a low pass impulse response here. Identifying whether you have a high or low pass filter from an image, and then intuitively do a convolution of a high or low pass filter on some complex waveform. Homework 4, we're going right into the Laplace transform, finding the Laplace transform of steps and ramp functions, and then finding the convolution of two signals using Laplace transform. All right, and then we deriving transfer functions of op amps first order and low pass op amp based filters. As we get into homework 5, you need to be able to do the asymptotic plot of transfer functions. That's magnitude and phase when you say Bodhi. Um, Also, if I input a sine wave and I know HS, what's my output? Um, Identify why a transient response of an op amp circuit might not match what the Bodhi plot would tell you. Again, you might not understand any of this if this is your first day of class. Then homework 5A, we have a review. You need to be able to use the mesh, nodal, and intuitive methods to find the output-input relationship. Now here's an interview question. Derive the transfer function, plot its Bode plot, find the time domain equation, and then plot out the time domain response, and then identify whether it's a high or low pass thing. High level, research applications for high and low pass filters. Homework 6, derive the output function of ideal op-amp circuits for various combinations of inverting and non-inverting summers. This is really critical to the final project and the notch filter in EE110 lab. Derive the output functions of inverting integrator. You need to know this cold because the DF2 method relies on inverting integrators. And then create op-amp circuits. Yep, I know the spelling's really bad here. I just thought to get this out to you before the exam. I'll probably redo this video. Homework 7, estimate the number of op-amps based on how a DF1 or DF2 implementation. So I give you some high-level functions. Which way is the best way to go? In homework 8, we talk about the gain bandwidth, and you have to be able to identify the effects of gain bandwidth of an op-amp. Then identify non-idealities caused by a finite gain bandwidth of an op-amp. Identify systems that demonstrate positive feedback, and identify some uses of it. Then you're going to model the op-amp circuit's behavior when the open loop gain is modeled as a constant, integrator, low-pass filter, and a second-order low-pass filter. Homework 10, we model spring damper mass systems with an RLC circuit. Then you got to identify whether that circuit is overcritical or underdamped. And then we use the control. Another task you need to be able to do is using the control system methodology, derive the transfer function of an op-amp circuit. Then we talk about stability. Why is a system explain why a system is unstable? Explain mathematically. Prove whether it can be stabilized with proportional plus derivative, or proportional plus integrative feedback. Identify possible reasons why a system is not behaving like it should. All right. Homework 11, identify a transfer function from a Bode plot. Homework 12, do almost the same thing but from a step response. Homework 13, identify complex poles and zeros from a magnitude versus frequency plot. Not a Bode plot, by the way. Homework 14, identify different types of modulations. Now in midterm 1, what did you need to have to do? Model a signal as a sum of step and ramp functions, sketch Bode plots, and identify what kind of filters produce an output response given an input signal. Another task is pass an interview. And it's this skip one right here. Derive HS, sketch the Bode plot, find a time domain equation, and sketch the time domain response. And the last question is derive and plot the convolution of two simple signals. Midterm 2, architect a system using the DF2 style. Model spring damper mass systems as RLC and determine the conditions for over, under, and critical damped. Use this control system methodology to derive the output response of an op-amp circuit using various models for the gain versus frequency of the op-amp. Identify if you're going to see under, over, or critical damped response. Identify which method will stabilize an unstable system by proving it mathematically. Find the period and DC average of various signals and match various time domain signals to their FT plots. On the final, which includes questions from, there'll be a section midterm 1 and a section midterm 2, which I covered before. And if you do better on the final on these two, it can boost your grade on the original midterm 1 and midterm 2. However, these grades here will not affect the final, but just the final is cumulative. Identify the transfer function from a Bode plot, identify system properties from a step response, and then you're going to give a high-level system design task. How many subsystems do you think there are? Is there feedback between this and that? How would you break the project up so the team could work on it? If you were testing the system by itself, how would you do that? Right? That's a super high level that you should be able to tie everything together. I realized that I was mostly reading the slides. Um, Hopefully this will help you prepare for the exam and uh, understand what it was you were doing all this time in 110.